Hello everyone, my name is Manvendra Singh, and I'm a solar design engineer. In today's video, I will walk you through the complete drafting process I follow for creating accurate and professional designs in AutoCAD, especially for solar permit plans. Drafting is the foundation of design engineering. Whether it's solar, architecture, or mechanical work, a good drafting process ensures that your drawings are not only technically correct, but also easy for engineers, inspectors, and installers to understand. So let's get started step by step. Step 1. Understanding project requirements. The very first step in drafting is to understand the project requirements. Before opening AutoCAD, I carefully go through the project details. For a solar design, this includes reviewing the site plan or roof plan, checking the client's requirements such as system size, battery backup, or ground mount versus rooftop, looking at utility and AHJ, authority having jurisdiction requirements, since different cities and states have different codes, making sure I have the inverter type, module type, and number of panels finalized. It's also important to check fire code setbacks, row spacing, and any shading issues. At this stage, I usually create a quick checklist. This saves a lot of time because once you begin drafting, you don't want to stop and go back searching for information. Step 2. Setting up drawing template 1.5 min. Now that I understand the project, I move to AutoCAD and set up my drawing environment. I always start with a template file. My template already has layers for roof, panels, conduit, electrical symbols, text, and dimensions. Predefined scale, so I don't waste time adjusting later. A title block with company information, project name, and sheet number. Using proper layers is very important. For example, panels should be on one layer, conduit on another, and text on another. This keeps the drawing clean and easy to modify. I also prepare sheet sizes like 11x17 or 24x36, depending on client or utility requirements. Pro tip: if you keep your template ready, it can save you almost 30 to 40% of your drafting time in future projects. Step 3. Importing and cleaning base plan. The next step is to bring in the base plan. Most of the time, we get a PDF or a DWG file of the property or roof plan. If it's a PDF, I use AutoCAD's import feature or trace it. Once imported, I scale it properly using a known measurement like a property line or roof length. After importing, I always clean the drawing. This means deleting unnecessary layers, text, or objects that don't add value. A clean drawing ensures that the final plan doesn't look messy. At this stage, I also add important elements like the north arrow, property lines, and fire setbacks. Remember, if your base plan isn't neat, your final output will never look professional. Step 4. Module layout. Now comes the most important part, the module layout. This is where I start placing solar panels on the roof or ground area. I use blocks for PV modules so that the file size remains small and editing becomes easy. While placing modules, I focus on proper alignment in portrait or landscape, spacing between rows to avoid shading, maintaining fire code setbacks from roof edges, ridges, and valleys. For ground mounts, keeping enough row-to-row spacing to prevent shading during winter months. I also consider the tilt angle and orientation, usually south-facing for maximum production. This step defines the system capacity, so accuracy here is critical. A wrong layout can affect system size, cost, and even client approval. Step 5. Electrical details. Once the module layout is ready, I move to the electrical part of drafting. I start placing components such as inverters, disconnect switches, combiner boxes if needed, main service panel or load center. Then I draw the conduit path from the modules to the inverter and from the inverter to the main panel. I make sure the path is logical, clear, and not too complicated. This is also where I prepare the single line diagram (SLD). In the SLD, I show the electrical flow from modules to inverter, then to disconnect, and finally to the grid or load center. If the system uses optimizers or microinverters, I show them clearly in the wiring diagram. Pro tip: always label your wiring sizes and component ratings. This makes it easy for installers and inspectors to verify compliance. Step 6. Annotation and dimensioning. Once all elements are in place, I add annotations and dimensions. Annotations include module type and wattage, inverter model, conductor and conduit sizes, NEC compliance notes. Dimensions are used for setbacks, row spacing, or trenching distances. Using consistent text style and dimension style makes your drawing look professional and easy to read. Step 7. Final sheet preparation. After drafting all details, I prepare the final sheet. I arrange the roof layout, electrical diagram, and legends properly in the sheet. I add a legend for symbols, general notes, and company information in the title block. Finally, I double-check everything and export the drawing to PDF format for client or utility submission. Conclusion. And that completes the drafting process I follow for solar permit design in AutoCAD. To quickly recap: understand the project requirements. Set up your drawing template. Import and clean the base plan. Place the module layout. Add electrical details and single-line diagram. Annotate and dimension. Finalize the sheet and export. Thank you so much for watching this video. If you found it useful, please don't forget to like, share, and subscribe to my channel for more tutorials on drafting and solar design.